Good afternoon. Thanks for joining me again. Today we're going to be reviewing a project that we did in West Texas on a pecan farm. This particular pumping station was designed to deliver 1,600 gallons a minute. Now, once we review the hydraulic design, it'll show an icon for the pumping station. Typically, we try to locate the pumping station as close to the center of the distribution of the water as possible. That may be in the center of the farm geographically, and it may not be. It depends on if the distribution is greater on one side of the farm or the other, then the pump station will be located accordingly. The drawing is going to detail the suction line, the centrifugal pump, the drive for the pump, whether it's electric or diesel. This particular farm happened to be electric. The anti-siphon device, which is a backflow preventer, a steel manifold, the filter, the water meter, and then finally the connection to the PVC main. Now remember, and we discussed this in an earlier video, the suction line, if it's not flooded, can't be more than 100 feet from the water source. Additionally, the distance to lift the water from the top of the water source to the face of the centrifugal pump or the volute should not be more than 12 feet. The suction line itself is going to be sized by maintaining a 5 feet per second velocity for any given water flow in gallon per minute. The length of the suction line is established by allowing 10 inches for every 1 inch of pipe diameter. This is going to allow for laminar flow as the water enters the centrifugal pump. Again, unless the farmer requests different, when we use centrifugal pumps, we use Cornell centrifugal pumps. The centrifugal pump is driven by an electric motor or a diesel engine, and that horsepower for either the motor or the engine will be evaluated based on lift, total flow in gallons per minute, and the pressure required at the centrifugal pump discharge head. Our centrifugal pump is going to be driven by an electric motor or a diesel engine. Now on this particular project, it was an electric motor, and you'll see that in the drawings when we refer to them. The horsepower for that electric motor was evaluated based on lift, total flow in GPM, gallons per minute, and the pressure required at the centrifugal pump discharge head. The first thing we're going to enter is a butterfly valve, which allows us to prime. It seals the volute. The next item will be a backflow preventer, which is called an anti-siphon device, and generally we'll have two. The anti-siphon device is a backflow prevention device. It's installed anywhere between the water source and the injection point for the fertilizer, insecticides, or other amendments. The filter selection is important, as filters are specifically designed for different types of debris and density of debris. Spin clean style filters are designed for sediment with a specific gravity of 1.5 or greater, which means inorganic sand and sediment. Sand media filters are able to filter all debris, both organic and inorganic, but they require a large footprint. We think the best of all worlds is the automatic screen filter. When sizing a filter element, it's matched to the emitter orifice of the irrigation system. The water meter is installed downstream of the filter and also requires laminar flow for accurate readings. 10 inches of distance for every 1 inch of pipe diameter upstream of the meter, and we've talked about this before in previous videos, and then 5 inches of distance for every 1 inch of pipe diameter downstream. If necessary, these distances can be reduced by adding straightening vanes to the water meter installation. Now, when we connect these major components of the pumping station, we try to use steel or black iron from the pump to the filter. After the filter, we transition to PVC and we stay PVC. We find that if we have steel components, transition to PVC, then transition back to steel, we experience leaks due to vibration. We also use continuous acting air vents and pressure relief valves, and we use them all over the pumping station and all over the field, and especially when we change elevation. Let's take a minute and review the typical drawing for the centrifugal pumping station. All right, this pumping station is installed on a pecan grove in West Texas, a place called Van Horn, Texas. The 1,600 gallons a minute that we require is pumped to this point, but the pressure is only about 10 psi. So we have all the volume we need, but we don't have the pressure. Our centrifugal pump installation is taking 1,600 gallons per minute at 10 psi and making it 1,600 gallons a minute at about 70 psi. But you can see with the drawing, first thing we have an eccentric so that we have laminar flow heading into the face of the pump. Then we go to our butterfly valve for priming. After we leave the butterfly valve, we have two 8-inch anti-siphons. Here we have a steel fitting, a concentric, that increases the pipe size. We go into a steel T, two more steel 10-inch 90s, and now we're into two 8-inch sand separators. The water quality is so bad that we knew it would overwhelm the automatic screen filter. The first thing we had to do is direct the water through sand separators and then finally into our 10-inch automatic screen filter. Both the automatic screen filter and the two sand separators are both automated, and they flush on pressure differential. Finally, the water is directed through a 12-inch control valve and into the main line. Alrighty, enough of that. Listen, put your boots on, I'll do the same, and we're going to go join our crews as we install this centrifugal pumping station. Okay, we've covered an awful lot of ground in the office, and so now we're going to see each of these components individually. We'll do two things. We'll go part by part for each of the components, then we'll follow the water flow. But remember one thing, don't be intimidated by the size. Every centrifugal pump station is going to have the same componentry as you walk through the entire process. The size will increase or decrease depending on flow rate and hydraulics. So here today, all we're going to do is just make sure we see all the components. Immediately, the very first thing we have is our suction line. And we talked about laminar flow. So you can see this suction line is more than 120 inches long because it's 12-inch. That's going to allow the water to pass through the last fitting, and it'll start to go laminar and get flat and enter the face of the pump. The next fitting that we see, we talked about also, is called an eccentric reducer. The top of that reducing fitting will be flat. The bottom is going to be curved, again to aid in laminar flow. Now the water enters the centrifugal pump. I talked earlier about how much we like Cornell pumps, and that's what you have here. After it leaves the Cornell pump, it goes into a gear-operated butterfly valve, primarily for priming. So if we ever lose prime, we can close this valve, reprime. This valve stays open most of the time. From there, the water goes through a backflow preventer. This is going to be required in almost every agricultural area we work in. It's really important for whatever we're injecting downstream to not enter the water source, and that's what the backflow preventer does. It has a low pressure drain, it has an air vent, and it has a check valve inside. After the backflow prevention, the water's going to move into steel manifolds, and it's going to enter our favorite filter. We use this filter over and over again. It's an automatic screen filter, and the manufacturer is VAF. But anyways, the water moves through the filter. This filter will take the water down to about 120 micron, which is about 120 mesh. We use mesh in the agricultural community, and we use micron in municipal and commercial, but that's where they intersect. So we're going to be at 120 mesh or micron. Now you'll see another gear-operated butterfly valve. It's for flushing if we ever get in a situation where we need to power flush the filter element. But then the water moves through. The very next component we're going to pass is a propeller meter. And again, now we're back to laminar flow. So once the water's moved through all this, it's crazy. It's moving like this, but it has to get flat again so we can get a good reading on this propeller meter. So again, you're going to see this is now 10-inch pipe. And so we have 100 inches upstream of the propeller meter. We have 50 inches downstream. Then the water is going to enter into where the main line starts. And we put an air vent on there because we're changing elevation. And everywhere we change elevation, we try to install an air vent. Now let's follow the water flow, and we kind of did that with the parts, but let's follow the water flow. Water comes from the water source, enters into the suction line. Suction line passes through the eccentric reducer and into the face of the pump. You see a gauge here. This is really nice. It's not a pressure gauge, it's a vacuum gauge, and it measures vacuum in inches. It's a nice troubleshooting tool. If we have a problem with the pump, the very first thing we check is the vacuum gauge. And if it's running, you know, anywhere north of 8, 7.5 or 8 or 8.5 inches of vacuum, we know we have a problem on the suction side. But the water passes into the pump. This particular pump is driven by a diesel engine. Availability of electric power is pretty minimal in rural areas, and so typically we're using diesel engines to drive the pump. Again, this is a concentric reducer. You can see that it is curved on top and bottom. So it's not necessary to have a flat top on the discharge side of the pump, only on the suction side. Then we pass into the backflow preventer, which we talked about earlier. The backflow preventer passes into steel manifolding. Filters are sized based on flow rate. This is approximately 2,000 gallons a minute. There's 1,000 passing through each of these two filter bodies. It gets filtered to 120 mesh or 120 micron. Passes into PVC. Now we're in what we consider our main line. But the first thing we have to do is get the flow back to laminar. We go through the meter. We have a propeller meter here. Then we enter the water's introduced into the main line. So you can reach us over the telephone at 772-468-0888 or on the web at asi.ag. I hope we're helpful, and thank you for allowing me to do what I love to do. Talk to you soon.